Effects from thunder and lightning. Lightning and thunder have occurred as natural phenomenons since the dawning of time. Scientists have since been attempting to understand how thunder and lightning work hand in hand, as well as their effects on humans and nature. Our better understanding of these phenomena have led to better protection from the potentially destructive effects. Lightning effects on humans. Whereas industrial shock carries 20 to 63 kilovolts, a lightning strike delivers a whopping 300 kilovolts, according to the NASA Science website. Electrical currents from lightning strikes have a shorter duration than industrial shocks, averaging a few milliseconds per strike. When a human gets exposed to a lightning strike, an external flashover occurs wherein the electrical current passes over the surface of the body. This can result in burns, mostly in the upper and lower body, specifically the head, shoulders and neck. Injury can also occur from the lightning bolts making the victim fall or throwing him through the air. Immediate death from a lightning strike is usually attributed to cardiac or cardiopulmonary arrest. 9,007 people have been killed via lightning strikes between 1940 and 2003, according to Michael Largo, author of Final Exits, The Illustrated History of How We Die. Lightning in nature. Lightning has a positive electrical charge, traveling between the base of a thundercloud and the point of contact on Earth in approximately 30 seconds. The process of lightning strikes attraction to specific objects is not yet fully understood by scientists, yet they know lightning tends to strike tall, freestanding structures, such as radio towers, telephones poles and trees, much more often than open ground. About 20 million lightning strikes hit the United States each year, according to Largo. Thunder sound effects. Thunder occurs as an acoustical effect of high temperature and pressure during a lightning storm. The great change in pressure affects the human ears, causing them to hear thunder. The highest pressure in a storm happens a few centimeters away from the origin of the lightning strike, causing a rumbling noise. Thunder mechanical effect. The pressure which results in thunder doesn't just have acoustical effects but mechanical ones. The high pressure of these lightning strikes can cause earthly damage, especially to metal objects. The pressure can be even more destructive when lightning strikes a small, closed area, such as a crack in a wall or a capillary in a tree. When pressure gets high enough and passes through tree capillary, the tree can explode. Effective lightning strike. Different effects. The effects of lightning are those of a high-strength impulse current that propagates initially in a gaseous environment, and then in a solid, more or less conductive medium. Visual effects. Caused by the Townsend avalanche mechanism. Acoustic effects. Caused by the propagation of a shock wave originating in the discharge path. This effect is perceptible up to a range of around 10 kilometers. Thermal effect. Heat generated by the Joule effect in the ionized channel. Electrodynamic effects. These are the mechanical forces applied to the conductors placed in a magnetic field created by the high voltage circulation. They may result in deformations. Electrochemical effects. These relatively minor effects consist in the form of electrolytic decomposition in accordance with Faraday's law. Induction effects. In a varying electromagnetic field, each conductor becomes the seat of an induced current. Effects on a living being. The passage of a transient current of a certain RMS value is sufficient to incur risks of electrocution by heart attack or respiratory failure, together with the risk of burns. Lightning causes two major types of accidents. Accidents caused by a direct stroke when the lightning strikes a building or a specific zone. This can cause considerable damage, usually by fire. In order to prevent any risk of accident, lightning air terminals should be used. Accidents caused indirectly, as when the lightning strikes or causes power surges in power cables or transmission links. Hence the need to protect with SPD the equipment at risk against the surge voltage and indirect currents generated. Direct effects. Thermal effects. These effects are linked to the amount of charge associated with lightning strikes. They result in fusion points, melting holes of varying sizes at the point of impact of materials with high resistivity. For material which is a poor conductor, a large amount of energy is released in the form of heat. The heating of water vapor contained in the material results in very high abrupt localized pressure which may cause it to explode. Effects due to the initiation. In the event of a lightning strike, a substantial increase in the ground potential of the installation will occur depending on the grounding network and soil resistivity. Potential differences will also be created between various metal elements. Hence the need to pay particular attention when installing earth rods and interconnection of metal structures adjoining the conductors. Acoustic effects. Thunder. Thunder is due to the sudden increase in pressure of the discharge channel developed by the electrodynamic forces during the lightning flash. The duration of a thunderclap depends on the length of the ionized channel. For high frequencies, propagation of the spectral components released by the shock wave is perpendicular to the channel. For low frequencies, propagation is omnidirectional, hence the different forms of rumbling or claps heard by an observer according to the distance and orientation of the successive channels used by the lightning flash. Luminous effects. A lightning strike nearby violently sensitizes the retina of an observer. The eye is dazzled and vision is lost for several long seconds. Electrodynamic effects. Electrodynamic effects between conductors and other parts occur due to large magnetic field of the lightning current. This results in substantial mechanical forces, both attractive and repulsive, that are all the stronger when the conductors are close together or the current is high. Electrochemical effects. The fleeting nature of lightning impacts mean that these effects are highly negligible and without influence on earth rods. Indirect effects. The ever-increasing use of sensitive electronics means that electrical equipment is becoming more and more vulnerable to transient overvoltages caused by lightning. The overvoltages are either of atmospheric origin or industrial origin. The most harmful are, however, atmospheric overvoltages, which are the result of three main effects. Conduction. An overvoltage that propagates along a conductor which has been in direct contact with the lightning strike. This effect is all the more destructive as the majority of the lightning energy is propagated through the entire network. This problem is resolved by fitting the installation with suitable device able to support high currents. Induction. Caused by the electromagnetic field radiated by the lightning strike. It generates an overvoltage on conductors within a range that is proportional to the power and the rate of speed variation of the lightning strike. Consequently, under the influence of abrupt variations in current, the cables, and even the ducts which act as aerials, may be subjected to destructive overvoltages. This is the reason that placing the network underground does not guarantee lightning protection. Rising up from the ground. When a lightning strike hits, an overvoltage can rise up from the ground attempting to find a more favorable path to ground. This can, in part, be dealt with through equipotential bonding between the metal structures and ground of the entire installation of a structure. Overvoltage protection installed on services. Thunderstorms affect health. Thunderstorms are dramatic events, so it's not surprising that they often bring out powerful emotions, ranging from excitement to fear. And for people with chronic illnesses, strong emotions can sometimes contribute to physical symptoms. They might worsen an asthma attack, for example, or make it harder to manage an arthritis flare. Yet there's more to the story than that. According to experts in human biometeorology, the scientific study of the interaction between atmospheric processes and human health. Research suggests that there may also be a more direct link between stormy weather and wheezy airways or achy joints. Here's what science says about the complex connection between mind, body, and thunderstorms. Thunderstorm asthma. Over the past 3 decades, scientists have reported mass outbreaks of asthma attacks associated with thunderstorms in Great Britain, Australia, and Canada. During these outbreaks, emergency room visits for asthma jumped to 5 to 10 times the usual rate. Stress and anxiety may have played a role. Many asthma patients are children, and fear of thunder and lightning is common in young kids. Usually, the fear fades as children get older, but a milder version of the primal response to booming thunder and crackling lightning may stick around. In someone with asthma, chemicals released by the body when under stress can cause muscles around the airways to constrict, making it more difficult to breathe. Pollen is another factor tying summer thunderstorms to asthma. According to one popular theory, updrafts carry whole pollens into the cloud base of the storm, where they break open into an easier-to-inhale form. When the storm starts, downdrafts carry the pollen pieces back to ground level, where they can easily trigger allergy and asthma symptoms. But that's not all. In a 2009 article, scientists from the University of Georgia and Emory University noted that, when a thunderstorm strikes, air temperature tends to plummet. In people with asthma, rapid cooling of the airways can make symptoms worse. Plus, each flash of lightning produces a puff of nitrogen oxide gas, which can then react with sunlight and other gases to produce ground-level ozone. People with asthma are more sensitive to ozone in the air, which raises the risk for asthma attacks. Rainy day arthritis. Many people with arthritis swear by their ability to predict coming storms by how their achy joints are feeling. To some extent, this may be a case where believing is seeing. People believe that there is a link between arthritis pain and storms, so they notice when these two events coincide, and they fail to notice all the times when their arthritis flares up in fair weather. In a study published several years ago, researchers from the University of Toronto and Stanford University showed college students 6 pairs of graphs. The top graph in each pair was said to show changes in a patient's daily arthritis pain, and the bottom graph was said to show daily barometric pressure for the same period. In reality, the graphs had been created for the study. One showed pain and barometric pressure moving in the same direction. One showed them moving in opposite directions. And 4 showed no consistent relationship at all. Almost all the students correctly identified the patterns in the first 2 graphs. But they tended to see patterns in the other graphs as well. They were looking for a pattern, and they found it, even where it didn't exist. Still, the belief that arthritis gets worse on rainy days is so prevalent among both patients and rheumatologists that it's hard to discount completely. Studies that have tried to confirm the connection have produced mixed results, but that may just be because it's such a difficult issue to study. Some scientists blame the increased pain on a drop in barometric pressure, which often precedes a storm. As pressure around a joint drops, tissues expand slightly. If there's already swelling in the joint due to arthritis, people may feel this change more acutely. In surveys, up to 2/3 of people with arthritis say their symptoms are affected by the weather. The Weather Channel even offers an aches and pains forecast. My own forecast for thunderstorm season is steadily rising. Interest in the fascinating interplay between mind, body, and weather. The thousands of thunderstorms on Earth each day produce millions of flashes of lightning, most of which occur in tropical and subtropical areas. Most are harmless, but a number of them strike airplanes, buildings, ships, and people. A direct strike to a plane, building, or ship can cause fire or other damage. A direct strike to a person can cause serious injuries or death.